Okay, so for this last section of the notes, I want to talk about what happens when you start messing with your sine and your cosine function. So what we are going to be talking about is we'll talk about vertical and horizontal compressions and stretchings first, um, and horizontal. Um, and then next time we will be talking about what happens when you shift it around, when you shift these graphs around. Okay, so these vertical and horizontal stretches and compressions, if you recall from your 1050 class, you may have been graphing things like you'd look at y equals x squared. So you'd look at a graph and it would look something like this. Sorry, I didn't touch the origin there. Okay, that's a little bit better. All right, so you'd look at that guy, but then you would also look at things like y equals 2x squared. And when you added that 2 in front of it, remember it stretched it vertically. You got this nice little stretch. And then when you put in a number between 0 and 1 in front of it, so something like 1/2, then that made it a little bit fatter. So you'd end up with a graph that looked something like that. And so you would get these three different circumstances. There's the normal circumstance where the number in front of your function is just 1. There's the second one, which is a vertical stretch. It stretches this graph vertically, and it is when the number outside of the function is greater than 1. And then when that number outside of the function is less than 1 but greater than 0, then we end up with a fatter graph. It compresses it vertically, is what's happening there. So I want to know if I'm using sine or cosine, what happens with that number in the front. So I'm going to call it a big A. I'm going to use A. You'll see later that that A stands for amplitude. So I want to know what happens when I change the A. When A does not equal 1, as it generally does if you don't see an A there. So what happens when y equals 1/2 of sine x? And what happens when y equals 2 of sine x? What is going to happen to these graphs? And so if you look back up here to the example that we just saw, well, this one should give us a vertical compression. And this one here should give us a vertical stretch in our sine graph. So to take a look at that, I'm actually going to flip over to a graphing calculator. There's a free online graphing calculator you guys are all welcome to use. There's actually a couple of them. The first one I'm going to look at is called Desmos. It's desmos.com. So if you go to desmos.com, this is what you'll come up with. It'll look just like this, and you just have to click Start Graphing. So you can click that Start Graphing. Unfortunately, Desmos doesn't have an app on your phone. If you don't have any kind of graphing calculator, you can use apps on your phone. The one that I would suggest using is GeoGebra. If you look up GeoGebra graphing, then that is also another free program you can use on your GeoGebra.org is what it's called. It's a free program. You can use it on the internet. You can use it on your phone. I have it on my phone. I use it a lot if I'm in a pinch and I need to use something. Okay, so your GeoGebra, when you first type it in, it won't look quite like what mine did because I'm signed in. And you can just click on Graphing Calculator. And when you click on that, then it will bring up a nice little app to help you graph. So you type in whatever equation you want right here. You can use this keyboard down here. This is much what the app looks like as well. I'm going to go back to Desmos because I kind of like the format of Desmos. So I'm going to just put in a y equals sine of x graph. So when I do that, you can see that this graph comes up in red. It shows me some key points there. It'll say, oh, look, that's negative 3 pi halves and 1. There's negative pi and 0. And so there's our graph. We've already made one of these. It looks pretty normal to what we are used to. So then the question is what happens when you change things around? So what if I have y equals 1/2 of sine of x? Then what happens with that? Well, it's graphed in blue, you know, because it has this blue color over here. So it's graphed in blue, and it has those key points again. Notice that with this graph, I am a little bit less than my red graph up there. I am half the length of that red graph, actually. So it has compressed my graph. It has done a vertical compression, as we thought it would. So that means we should get a vertical stretching if we put in our 2 sine of x. So that one's in green, and you can see that it has stretched it, so it is twice the height of our first graph. So this number that we put in front of our sine or our cosine, the same thing happens with cosine. You can go ahead and try it with your cosine if you would like to. It's changing the amplitude of our graph. You can do a general version of this. This is what I kind of like about these, is it will add this slider. So this one has plotted it as the orange graph on there. I'm going to go ahead and turn off the green one and the blue one. And as I change this orange graph, as I change the amplitude, that A, it's changing the number that's right here, and that number matches this number down here. So right now it's at 6.1. So my amplitude is 6.1. And I can move that around. I can flip it upside down. I can do all kinds of things. Notice that it has these points. In physics, I believe they call them nodes. This right here, that point, would be considered a node. And no matter what I do when I'm changing my amplitude, those nodes don't change. They aren't going to move around. So I just always have those little points. So that's what happens when I change my sine graph, that A value in front of my sine graph, is I get that different amplitude that I'm looking at. So let's go ahead and go back to the notes here. And sure enough, when I change my value that's right there, I say that A controls the amplitude. Now, careful with it, because if it's a negative value, then that's not amplitude. Amplitude isn't a negative value. So amplitude, if you want to find amplitude, then amplitude is equal to the absolute value of A. So the absolute value just takes away any negatives. It's the negative of a negative number, making it a positive, because amplitude just needs to be a distance, the distance away from equilibrium. So that's what we call that. We are changing our amplitude. So if I had an example of that, I could go ahead and take a look at, well, what if I have y equals -3 sine of x? Then this guy, I would be able to just take a look and I'd say, oh, well, my amplitude is automatically, I can say 3, because it's the absolute value of this A number. So that number there is -3, the absolute value is +3, so my amplitude is 3. So if I were to graph that and just think about a graph really quick, then I'd be able to say, oh, well, it doesn't just stop at 1, it goes all the way up to 3 and all the way down to -3. So I'd have my normal sine graph, and it would go all the way up and all the way down, and it would make the similar motion that I'm used to, but it would just be higher than I would normally think of. So that is what amplitude is all about. Okay, and then the last thing that we need to cover today is the period of the function. So the period of the function is determined by the the number on the inside of your graph. So when I have y equals sine of x, if I have a number b, we use a capital B on the inside there, then this b is going to help determine the period. And this gets a little bit funny. The period for a function is equal to 2 pi divided by b. So it's that 2 pi, it's one normal period of a sine and cosine function, and it's divided by the b. So if I were to just have y equals sine of x, and b then would be equal to 1, then my period is just 2 pi. So the normal function that we would look at of y equals sine of x, then we have a period of 2 pi because we're just dividing by 1. But you can change that period. So if I change that period, if I change that number that is there with the b, so let's say I have y equals sine of 2x, then I'm going to use that 2 in there to excuse me, sorry. I'm going to use that 2 to determine my new period. So my period for this function is equal to 2 pi divided by 2, which is the same thing as pi. So I have a period of pi. So that is going to change my function a little bit differently. What it's going to be doing is it'll make a horizontal stretch or a horizontal compression, depending on what that number is in there. This one is a horizontal compression. So if the number on the inside is greater than 1, then I have a horizontal compression. If it's less than 1 and greater than 0, then I'm going to end up with a horizontal stretch. It's going to stretch the function so it's longer. So let's go ahead and take a look at what that would look like using Desmos again. So let's go back over to Desmos, and I'm going to turn off these functions. So there's my normal sine function. And then what happens if I have y equals sine of, in parentheses, 2x? So when I get this y equals sine of 2x, then notice my function happens a lot faster. It's taking what was spread out over one period, so over that 2 pi, and it's taking it and it's compressing it so it just happens in a length of pi. So instead of looking at that stretch over the 2 pi, I'm now just looking at it over a stretch of pi. Whereas if I were to take that and make it sine equals 1/2 of x, then that one, it stretches it. So we had a compression, now I have a stretch. It's taking this function and it's stretching it out over 4 pi. So let's move over here and you can see that it stretches over 4 pi. So it goes up and down. It still has that same amplitude of 1, but it's stretched now over 4 pi instead of over 2 pi. So that means that every time I put a number inside of my parentheses with that x, so that number with the x, then it will be changing my period, how frequently I repeat. So as I change this, I can go down to negative, so it flipped. Then here it is, there it is, there it is. I can go all the way back to in between 0 and 1, and notice it is nice and long. It's long until I hit 1, and then it's the same, and then it starts getting shorter. We compress that period. And so that is what happens when you use that compression. And I'm running out of time, so I'm going to have to make one more short video for you.